So when doing story problems, it's best to underline information that you think will be important to helping you solve this problem. So as I read through it, I'll underline the things that I think will be useful. So the school that Stefan goes to is selling tickets to a chorale performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. So I'm putting a box around dollars because it's a dollar amount where these are like tickets, so different type of things. And then the school took in 52, so I'll put a box around that because it's dollars. On the second day, by selling 3 senior citizen tickets and 2 child tickets, find the price of a senior citizen ticket and the price of a child ticket. So what we've been doing is elimination, and what we have to do now is first create our equations based off of what we're given, and then we have to solve for each variable. And so it's easiest if we define our variables from the get-go. So I'm going to say x, and since senior citizens came first, I'll say x is going to be my senior citizen. Since it is a lot easier just to write x in our equation, it's going to stand for some number, but it's going to be some number of our senior citizen tickets. It's a lot easier to write an x than to rewrite that every time. So that's one of the reasons why we use variables. And then we're going to use y as basically the number of child tickets. And so we can start to develop our equations based off of what we're provided in the equation, the story problem. So we have 3 senior citizen tickets, so 3x, and 1 child ticket, plus 1y. So you can write 1y. I'm just going to write it as y. And that's equal to a total of 38. So dollar amounts is going on the end, I guess. And then we have, so that's kind of like my first equation. And then my second one is going to be, so 52. So since my box and the first one ended on the end, I'll put the 52, since it's in a box, on the end. And then, so on the second day, by selling 3 senior citizen tickets, so 3x yet again, and 2 child tickets, so plus 2y. And now they're kind of lined up, and as I start to look, my x's are the same value. So if you remember, we have to have 1 same value and 2 opposite signs. So 1's positive and 1's negative. So our x's are the same value, but we don't quite have opposites yet. Our y's, they aren't the same value, and they're not opposites, so that won't even work for us. So I think x is our best shot. And the way that we're going to turn one of them negative is just multiplying everything within this top equation by a negative sign. So I'll rewrite my equation down below. So if I distribute kind of like a -1 inwards to every term, I'll get a negative 3x. And now, since it's going to be -1 times a positive y, it's going to become a negative, so I'll put a minus y there. And that's equal to a -38. So everything became negative in our equation. And then we're going to treat it like addition. So I'll add this. Our x's will cancel as intended. And then we just add 2, and basically 2 minus 1, which will give us a positive 1y. And then 52 minus a 38 to give us 14. And so what that tells us is 1y equals 14, but in the context of our problem, one child ticket costs $14. Now we just need to find out what the senior citizen ticket cost. So now we'll plug in 14 for y. So I'll just use this top equation. We could use, this is basically like our third equation after we made it negative. We can use any of those three equations, but I'm just going to use our original first one. So 3x plus, and it would be y, but now we know that y is 14, so I'll put in 14, and that's equal to 38. So the first thing I'll do is subtract my 14 off, so minus 14, minus 14, and that's going to give me 24, and that's equal to 3x. Now I just need to divide by 3 and divide by 3, and so x equals 8. And so since we said that senior citizen tickets are x, one senior citizen ticket, that's an abbreviation, costs $8. So we've answered pretty much everything that the problem has asked us to do.